Guys, Mr. Bowman here, full screen ready to go today, but our learning objective is in red and we are learning to use probability trees to calculate the probability of combined events. And for this topic, we're looking at independent events only. We'll get into that in a little bit. But we've got a Pokemon up here. If you know who he is, in the comments below, give him a shout out. So back to this idea of independent events. We're looking for two events happening back to back. And independent events versus conditional events, they have a difference or they matter in terms of our probability. So thinking of the first two people, well, what's the probability that person number one has a dog? And what's the probability that person number two has a dog? The person number one is unlikely to affect person number two. So person number one, unlikely to affect person number two. When there is no effect to the probability, those events are independent. So this one here, they are independent. For example, when you got the marble, maybe we're going to get a blue one to start off with. And after that, you're interested in what's the probability of getting a red one. Well, when that happens, there's one less blue marble to pull, and there's one less in total. So that means the probability of red will be impacted by the probability of blue, and that makes it conditional. So that one there is a conditional event. So the probability of a red is impacted by what's happened before it. And this one over here, the first one, that there was independent because person two is unlikely to be impacted by person one. Hopefully that makes sense in terms of our independent events versus our conditional events. The main learning objective today relates to the idea of using probability trees. This is another tool like two-way tables, like Venn diagrams, that we can use to solve probability problems. So let's get into the first question. A penalty shootout, so that's in a game of football. The probability of Kai getting his penalty is 0.75, but the probability of Cole getting his is 0.9. These numbers and names are completely fictitious, nothing to do with anyone in our classes this year. Question number A. Draw a probability representing both players taking penalties. So maybe there's two penalties in a game. Kai takes the first one, Cole takes the second one. So what we need to do is we're going to start off with a bit of a dot and we're going to split this up. And this here relates to a certain event, and in our case that relates to Kai taking his penalty. And Kai either scores or doesn't score. The probability of Kai getting his one, we said, was 0.75. And this one here is 0.25, and that's because a branch or a splitting off, they have to add up to 1. After that, the second event takes place. Cole takes his shot. So we've got Cole scoring and then Cole not scoring. And the same thing, if Kai doesn't score, Cole could score or not score. So you can see two branches pop off based on Kai's success or not success on the previous question or the previous penalty. And this branch here is 0.9 because the probability of Cole scoring was 0.9, and the same here, 0.9, and that's the probability of Cole scoring. The remaining one is 0.1 because this whole branch has to add up to 1. And the same below, this whole branch here has to add up to 1. We then think about the outcomes after that. So you've got the outcomes. And this here is SS, which is scoring and scoring. We've got S and not scoring, and S, and then S dash, S dash. So not scoring, not scoring. In our case, this here would be 2 goals. This here would be 1 goal, and then 0 goals down the bottom. We now need to think about the probability of each of the branches. So that's why these questions are actually quite annoying to do. Probability, particularly when you're not given a tree to start off with. And when you're finding the probability, so we're looking at this SS branch, we kind of follow the branch backwards. Hopefully you can see what I did there. And that there would have been 0.75 times 0.9. And this is when you're going to need your calculator. I've got mine here. 0.75 times 0.9. That there comes to 0.675. We're then looking at our next outcome. Well, what's the probability of this? We follow it backwards. You can see it's 0.75 and 0.1. So 0.75 times 0.1. That there should be 0.075. And then we're looking at our next branch. Follow it backwards. So that's 0.25 and 0.9. 0.25 times 0.9. I'll need a calculator for that. 0.25 times 0.9, that gets me to 0.225, and then finally, last outcome, follow it back, 0.25 times 0.1. And I don't need a calculator for that, 0.025. So the number 1 comes up a lot in our probability trees. So we can see these add up to 1, these add up to 1, these add up to 1. And lastly, these numbers here represent all possible outcomes, so they should add up to 1. So if you add 0.675 plus 0.075 plus 0.225 plus 0.025, all of these should add up to 1. If it does, you know you've done it right. You haven't done any math errors anywhere. If it doesn't, maybe it's a good chance to review what you did. A lot of 1s coming up. So now that we've done our tree, we can now actually answer some questions, and normally these are a bit quicker. So calculate the probability that both are successful in their penalties. So probability, I'm going to write both successful. And we've now got to think of our branches up here, which of these would relate to being successful? So would this first branch do? Yes. No, no, and no. And these, because there's no 2 goals, there are only 1 or 0 goals. So we only care about these 2 goals. So the probability of that, 0.675. And that relates to the end of the branch over there. Question, I've gone into the green pen now. Calculate the probability of at least 1 successful. So probability at least 1 goal. And this one here, if you have a look at our scenarios, at least 1 goal, that's a yes, that's a yes, that's a yes. In this case here, that's a no. When you have multiple ticks, all you've got to do is add them up. So in our case, 0.675 plus 0.075 plus 0.225. And we do that on a calculator just to be sure. That comes to 0.975. You also could have calculated that by doing 1 minus 0.025, which is the only cross that we had there. That also would have got you to the same answer. So guys, hopefully you learned a bit from this video. We looked at independent events versus conditional events. Those are really important. All the ones we're going to do in today's questions relate to independent events. And we also looked at this fictitious penalty shootout scenario involving Kai and Cole. We drew a tree and we found out some probabilities. Thanks so much for watching, guys. Get your notes down, then get into heaps of practice.